The concept of too hot weather refers to an increase in average temperatures beyond what has been historically experienced, often measured by the number of extreme heat events per year, or the duration and intensity of heat waves. This phenomenon began emerging towards the latter part of the 20th century as global climate change intensified. One notable early development was the occurrence of unprecedentedly high summer temperatures in Europe during July 1983, where the average temperature reached 40 degrees C, 104 degrees F, resulting in thousands of deaths from heat-related causes. The link between such extreme events and anthropogenic climate change emerged around this time, with scientific research attributing these episodes to rising greenhouse gas emissions. Key developments since then include a consistent rise in global average temperatures, exacerbated by human activities like deforestation, fossil fuel consumption, and urbanization, contributing to the creation of heat islands. Studies indicate that between 1950 and 2020, there was an increase in the number of days with maximum temperatures exceeding 35 degrees C, 95 degrees F in many regions. For instance, by 2018, India experienced a record-breaking 43 days, where daily highs were above 46 degrees C, 115 degrees F, compared to just 11 days per year between 1970 and 1985. The consequences of these climate changes have been significant on societies, economies, and industries. In terms of health impacts, the frequency and intensity of heat-related illnesses like dehydration and heat exhaustion have risen, with mortality rates increasing in affected regions. Economically, agricultural productivity has declined due to longer growing seasons under extreme conditions, leading to reduced yields and food shortages in vulnerable areas. Industries such as tourism have also suffered from decreased visitor numbers during peak summer months. Looking towards the future, projections suggest that by 2050, average global temperatures could increase by about 1.5 degrees C compared to pre-industrial levels, with some regions experiencing even higher increases. This could result in more frequent and intense heat waves, as well as accelerated melting of polar ice caps, affecting sea level rise. However, mitigative measures such as carbon reduction strategies, increased urban green spaces, and water conservation initiatives can help lessen the severity of these effects. Enhancing AI-driven climate models to provide more precise predictions about future temperature changes could also be beneficial in informing targeted mitigation policies and adaptation strategies. These advancements would allow for better preparedness and proactive responses to extreme heat events, ultimately protecting public health, safeguarding economies, and preserving natural ecosystems.